Hello all, welcome back to the problem solving session on the topic K-means clustering algorithm. And in this case, I have considered 7 data points, namely P1 to P7, and initially I have grouped into 3 clusters. The clusters are C1, C2, C3 respectively. And the data points in C1 are P1, P2, P3, and data points in C2 is P4, and C3 is P5, P6, and P7, like this. If you plot all those data points in a 2D view, it will look like this. So in this data points, initially we are considering this data points, we have grouped in initial stage as 3 clusters, like this. Cluster 1 comprises of 1, 2, 3 data points. Cluster 2 comprises of 4th data point alone. Cluster 3 comprises of 3 data points, namely 5, 6 and 7. It's the initial grouping. Now, for each group, we are going to take the center mean of each cluster. That is, for first 3 data points, we are considering the mean as mu1, which is equal to, if you take, how you will take 1 plus 2 plus 1 whole divided by 3 for first point, and for y point 1 plus 1 plus 2 divided by 3, so you will get 4 by 3 in 4 by 3. For second data point, you don't have n number of data points, you have only one data point that form as a group, as our cluster. So mu2 will be the same, minus 1 comma minus 1. For third mean mu3, we need to do minus 2 minus 2 minus 2 whole divided by 3. You will get minus 6 divided by 3, you will get minus 2. And for y point, 1 plus of minus 1 plus 2, you will get 2 by 3. Fine. So in geometrical view, how your data points and the means will look like. For first cluster, the mean is 1.3 comma 1.3. For second cluster, it is minus 1 comma minus 1 at the same data point you will get. And for third cluster, you will get y3, which is mu3, which is equal to minus 2 comma 6.6. Right? Okay. For data point P1 comma 1, we have 3 columns of mu1, mu2, mu3, and final decision what we are going to make. In cluster mean, I am going to take the L2 norm, normally called as norm2 or L2 norm. Our first data point is 1, 1 minus of the first cluster mean, that is 4 by 3 into 4 by 3, 4 by 3 comma 4 by 3. So if you simplify this, you will get 1 minus of 4 by 3, which is equal to minus 1 by 3. Here also 1 minus 4 by 3, which is equal to minus 1 by 3, the whole square into norm 2. So you will get minus 1 by 3 whole square plus minus 1 by 3 whole square, you will get 2 by 9, which is equal to 0.22. Same way, the cluster mean between the data point 1 and the distance mean mu2 is as minus 1 comma minus 1. If you simplify this, 1 minus of minus 1 whole square, so you will get 2 square plus again 2 square. If you simplify this, you will get 8. And the relationship between data point 1 and the mean distance mu3, which is equal to 3 square plus 1 by 3 the whole square. If you simplify, you will get 9.11. So while making a decision, out of these 3 values, which value is less, either mu1, mu2 or mu3. If you see, 0.22 is less compared with 8 and 9.11. So it belongs to, data point 1 belongs to cluster 1. That's the decision or assignment we are going to make. Same way we need to do for remaining data points P2, P3, P4, P5, P6 and P7. For example, P2, if you do, the distance the value is become 0.55 and mu2 becomes 13 and the distance of mu3 is 16.11. Out of these 3, which value is less? First value is less, so it is C1. For 0.3, mu1 value is 0.55 and it is mu2 is 13 and mu3 is 10.7. Out of these 3, again mu1 is less, so it belongs to, data point 3 belongs to cluster 1. Now if you look at data point P4 of mu1, it is 10.88 and mu2 it is 0, and for mu3 it is 3.77. If we compare all those three values, the mu2 value is 0. So this P4 data point belongs to cluster 2. That is the decision I have made here, C2. For P5, if you check for mu1 it is 11.22, mu2 it is 5, and mu3 it is 0.11. So out of this 3, if mu3 value becomes less, so this P5 belongs to cluster C3. Same way repeat the process for remaining data points P6 and P7. After that, this is the initial cluster grouping. After first iteration, what we have achieved, P1, P2, P3 remains in the first cluster, but in second cluster, in addition to P4, we have one more data point that is added, that is called P6. And for third cluster, one more data point is removed compared to the previous one. So P5 and P7 is there, P6 moves to second cluster. So by comparing these two things, initial cluster and then the cluster at the end of first iteration, both are different. That is not equal. So we need to go for second iteration by considering the new group, a new cluster. Again, repeat the process from step number 2. We need to take the mean of all the individual clusters. So mu1 dash, which is equal to 1 plus 2 plus 1 divided by 3, which is equal to 4 by 3 again, and for y point it is 1 plus 1 plus 2 divided by 3, which is equal to 4 by 3. And for second data point, mu2 dash, which is equal to minus 1 plus of minus 2 divided by 2, which is equal to minus 3 by 2. Same way for minus 1 divided by 2, which is equal to minus 1. And same way do it for mu3 dash. You will get minus 2 comma 3 by 2. Now we can calculate the distance, cluster mean distance. Our first point data point P1 of 1 comma 1 of mu distance of 4 by 3, you will get same answer 0.22. And for first data point, which is second data point mu2 dash, it is minus 3 by 2 and minus 1, you will get something as 10.25 by Euclidean norm method. And first data point, which is mu3 dash, you will get 9.25. Out of these three values, 10.25, 9.25 and 0.22, this data point 1 belongs to mu1, that is cluster 1. Why? 0.22 is less compared with 10.25 and 9.25. So 0.22 belongs to first cluster. So this data point 1 belongs to C1. That's the decision or assignment we are made at this particular point. Same way, repeat the process for P2, P3, P4, P5 till P7. And if you see, interestingly, it remains same. P4, P5 belongs to C2 and C3 respectively, and P6, P7 belongs to C2 and C3 respectively. Why? For P6, first cluster it is 16.55, for C2 cluster is 0.25 and C3 cluster is 6.25. Out of these three, 0.25 is less, so 0.25 belongs to cluster 2, so P6 belongs to cluster 2. Now you frame the comparison chart. At the end of first iteration, this was the group, and this was the group or cluster framed by the end of iteration number 2. We can check there is no change in the data points. Each data points fixed with each cluster. So that means the iteration gets converged. So data points are grouped and it is finally converged at particular point. So both clusters are equal and clusters gets converged. Fine. And finally, this is how your geometric view will look like. For cluster 1, the data points are x1, x2, x3, and you can frame a group with a mean of 1.33, 1.33, and second cluster can frame like this. And then data point of x4 and x2 with a mean distance of minus 3, 2, minus 1. And for third cluster, it is a combination of x5 and x7, and it forms a mean with a group of value of minus 2, 3 by 2. And this is the correct classification by using k-means clustering algorithm. Thank you all. We'll meet again in another video.